Okay guys, so now we're going to start reviewing atoms. So it's all dealing with what is this, which I just told you is an atom, and how do we know, and more specifically, what type of atom is it, and how can we tell based on what we're looking at. Okay, so take a minute and see if you can remember the answers to these different things. Okay, so here are our answers. Elements that are solid, shiny, and malleable. Remember, malleable means we can flatten them into sheets. I think of it being hit with a mallet is where the word malleable comes from. They can also conduct electricity. This is our metals. We also have a group or column of elements when they share properties. They're called families. You can think of just like you probably share certain characteristics with members of your family. Different elements in the same family are going to be similar and have similar properties as well. Then we have things that are non-metals. These are basically the opposites of metals, so they're most likely gases, dull, brittle, which means they can fall apart easily and crumble, and they don't conduct electricity. Then we have our vertical up and down groups on the periodic table, and horizontal left and right periods. And so our families, again, the properties are going to go along with the group. So everything in a column going up and down are going to be similar characteristics. Okay, so remember this has to deal with our periodic table, and these are the different terms we need to know. So remember that our group, as I just said, go up and down. And then our periods are going to go across. And it's not the things that are going across that are going to be similar, but our families here that have similar characteristics are the things that go up and down. So argon here is going to be similar to helium and neon and everything else in its family. And neon is more similar to argon than it would be to fluorine because fluorine is next to it in the same period, but it's not in the same group. And then we need to know all these different words as well, which we'll review in a little bit. Okay, so take a second to remember where our metals, nonmetals, and metalloids are. Okay, so I'm actually going to start with our metalloids. These are along this staircase in this little zigzag here. So we have boron, silicon, germanium, arsenic, antimony, tellurium, plutonium, and astatine. You don't really have to know exactly which ones, just as long as you know that it's along this little zigzag here. Then we have our metals, and so these are going to be the ones to the left and under our staircase, and a lot of them you should be able to kind of intuitively know that are metals because we have things like iron over here, nickel, copper, zinc, aluminum. So these are things that we kind of think about being metals, but this includes the whole entire rest of the periodic table over here that are metals, as well as everything over here except for hydrogen, actually, because if you notice, our stairs actually stop before they get to hydrogen. So hydrogen is kind of like above our stairs, you can think about. So our non-metals then are going to be everything else up here to the right of our staircase, to the right of those metalloids, and then also hydrogen. So hydrogen is that one thing that we have to remember. That is a non-metal. Okay, so protons, electrons, and neutrons are also called subatomic particles. And so see if you can label which one is which. So here we have our large things with zero charge or neutral charge are our neutrons. We have large mass and a positive is our protons. And then our small negatively charged are our electrons. And all of this is in our song, in an atom of dust, positive protons, yeah, in the nucleus, with the neutrons of no charge, negative electrons they buzz, around the outside, yeah, of the nucleus, of the nucleus. So this has all of the different subatomic particles, their charges, and it tells you what's inside and outside of the nucleus. And so remember the things inside our nucleus are our neutrons and protons, and those are the things that have mass. Our electrons are the little tiny guys that are flying around everything else. Okay, so when identifying an atom, which is telling you what type of atom it is, what element it is, you only look at its protons. This is the number of protons. This is unique to each individual atom. So here, if we are looking at this one, we can count 1, 2, 3, 4, 5, 6 protons. And then we can actually go to a periodic table and look. Hydrogen has 1 proton, 2, 3, 4, 5, 6. So we can see 6 protons. That's going to be carbon. Okay, and so this one, as another way of showing it, protons here we have 12. So again, this tells us specifically that this is magnesium because magnesium has 12 protons. Okay, since atoms are neutral particles, which means there's no net charge, the opposite charges are, as opposed to charges that have, or particles that have charges, which are called ions. I'm not sure if we mentioned that a whole lot in class, but the important thing is atoms are mostly neutral. So that means the protons must equal the electrons. Our pluses and our minuses, our positive and negatives, must equal out so that everything is neutral. So if an atom has 20 protons, then it must have 20 electrons. Okay, so we can use that information to kind of help us figure out how many protons, neutrons, and electrons. Because I just said before that we have our protons and neutrons tell us the mass, which is our larger number on our periodic table. So you can see that there's a couple different numbers that we're given. We're given the 6 here for carbon, which tells us the number of protons. And then when it's neutral, it also tells us the number of electrons. And then we have the mass at the bottom, which here is 12.011. We'll round that to the nearest whole number, which would be 12, which tells us the protons and neutrons equal 12. So we can then figure out how many neutrons by subtracting out the number of protons. So for this example, here our protons are going to equal 6 because that number on that top is telling us that, and I'm having some problems writing apparently, so it's telling us that this number is how many protons. And remember, we just said that our protons need to equal our number of electrons when it's neutral. So therefore, this is also going to be 6. And then for neutrons, there's where we have to do a little bit of math. We have to look at the mass. We're going to round to 14. Mass is going to be the protons plus our neutrons. So we got to subtract out our 6 protons to give us 8. So here we have 8 neutrons. So we're going to practice some of these. So we also had these different acronyms to help us remember. We have our protons equals the atomic number, which is another word for this number up here, the smaller number, the number on top. It's also going to equal the number of electrons because it's going to be neutral. And then we have pro-Newman, which is telling us our protons plus our neutrons equal our mass number, which is this number here at the bottom. So see if you can figure out the number of protons, electrons, and neutrons for sulfur. So here we have 16, 16, and then we're going to do 32 minus 16, which gives us 16. Okay, and try this for hydrogen. We have 1, 1, and actually 0 neutrons because we're going to round this to 1 minus our 1 proton we already have to give us 0. Okay, try this for this next one. Okay, so this one might have been a little tricky because I actually switched where our numbers were. So we have 16 here is our number of protons. We can remember that because it's a smaller number. And our mass number up here is always going to be larger because it has our protons plus our neutrons. So it's going to be larger. And then to figure out our number of neutrons, we can do the 32 minus our 16 to get 16. Okay, so try this one. Okay, so we're going to have 12. We use our smaller number again for our protons, and that's going to equal our neutrons, and then, or our electrons, sorry. And then our neutrons, we will do 24 minus 12 from our protons to get us 12 neutrons. Okay, so this time, try to draw it when you're done for nitrogen. So nitrogen, we have 7 protons from this number. It's going to be equal to our electrons. Our neutrons, we will do 14, which is our mass number, minus 7. Our atomic number, so we have 7 neutrons as well. So we can draw this a couple different ways, but the big thing is that our protons are going to be in the center. I'm just going to write P for proton, and also our neutrons will be in our nucleus as well. And for neutrons, we have 7 of each of those, so we can draw that here. And then our electrons, I'm just going to draw on the outside. We have 7 of those. So there's a couple different ways you could draw this. Okay, so now I'm giving you a picture and I need you to figure out the number of protons, neutrons, and electrons. So try it now. So this one here, it's labeled, our green here, and they're labeled P for our protons. We have 3 of those. We also have 3 electrons out here, and we have 3 neutrons. And we can use that information to determine the atomic number and mass number as well. So our atomic number is going to be the number of protons, and then our mass number is going to equal our protons plus our neutrons, like up here. So it's going to be 3 plus 3 for our neutrons, so we have a mass number of 6. Okay, so try this one. We have 11 protons. We should have 11 electrons as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we do. They should be equal. And then our neutrons here, we're told we have 12. So to determine our mass number and atomic number, our atomic number is going to be our number of protons, and our mass number is our proton number plus our neutron number, so we have a mass number of 23. Okay, and that is our review for the atom.